Hi, how are you? In this lesson we will continue our discussion on um, integration techniques, and we have the trigonometric substitution to look at today. We will be integrating expressions that have something of this kind. I'm just going to write one expression that you might see in your trig substitution section. So if you have an expression that looks like this that you're asked to integrate, you'll be using this trigonometric substitution. So the thing about those things are those expressions are that what makes them different is the fact that they have expressions that look like this. They involve problems that look like 1 minus x squared, or something that looks like 1 plus x squared, or x squared minus 1, or even something that looks like 4 plus x squared. Or in general, though, I have a squared, some positive number, plus or minus some positive number times x squared. Usually the square root, usually to the power of 1/3, 3/2 or 5/2, something of that kind. But we may not have that also, and we might still be using the trig substitution. And in this, to apply this trig substitutions, I'll look at two important identities that we learned in our trig class. And everybody remembers this trig identity: sine squared theta plus cos squared theta equals 1, which gives us these two important identities: sine squared theta equals 1 minus cosine squared theta, and cosine squared theta equals 1 minus sine squared theta. These are the ones that are usually more usable than that one. And I'll be referring to this one, the other one, that sec squared theta minus tan squared theta equals 1. And this also gives us two useful identities: secant squared theta equals 1 plus tangent squared theta, and tangent squared theta is secant squared theta minus 1. Okay, so these are the key identities that we will be using. We can get by with those two. We don't need to use the cosecant cotangent pair identity. We can do that, but we can get by without using that one. I think those are good enough. And so the idea here is, see, if we see an expression that looks like this, then we see that x, if we wish x was cosine theta. And in that case, 1 minus x squared will be 1 minus cos squared theta, which is sine squared theta. So when you put it under the square root, that for the right values of theta becomes sine theta. So that's the main idea. Okay, so let's just see what let's see an example to illustrate that. Okay, so let's say I have the integral of x over the square root of 1 minus x squared dx to do. This is a relatively simple integral. I know we can do this using the straightforward regular u substitution, but I like to do this using the trig substitution. Okay, just for practice of it. Okay, to illustrate this example. All right, so here our problem has square root of 1 minus x squared, so it calls for either 1 equals cos squared theta, or 1 minus cos squared theta, or 1 minus sine squared theta. You could choose either one, and it makes no difference at all in your computations. So let's let u be, no, I said u, I meant, let's let x, so I wish x was cos theta is the idea. let's say x, let's let x be cosine theta. So what's dx then? Dx is negative sine theta d theta. Okay? So when x is cos theta, dx is minus sine theta d theta. That's what I'm going to put in for dx. Also, what happens to 1 minus x squared? Well, that is 1 minus cosine squared theta. Okay? Because x is cosine theta, so just put in cosine theta here. Well, this is the square root of sine squared theta. Well, this is equal to sine theta for the appropriate values of theta when theta is in first and second quadrant. If theta is between 0 and pi, this square root of sine squared theta is really sine of theta. So then our integral becomes x over the square root of 1 minus x squared dx, which equals x over square root of 1 minus x squared, this guy is sine theta, so I'm going to put sine theta in for it. Okay, times dx is minus sine theta d theta. So that cancels. Oh, I'm sorry. I didn't put cos theta in for x. Okay? That was a big mistake. So I have cosine theta, and this is sine theta, dx is minus sine theta d theta, and so the sine theta cancels out. That gives us minus of the integral cosine theta d theta, and the integral cosine theta d theta is sine theta plus c. But now we're kind of stuck here. I have sine theta. I like to give my solution in terms of x. I don't know what sine theta is. What I know is cosine theta equals x. But lucky for me, I have sine theta here, which equals square root of 1 minus x squared. That is calculated. In most cases, this is not, or in many cases, it's not the case, and we have to use some other technique to calculate what this expression is. But in this case, I have a lucky case. I have minus of sine theta, which equals square root of 1 minus x squared, and I'm done. So this is the solution to this integral. Alright, now what I want to say is this is just one particular example for one particular case, and so to continue the introduction of this lesson, I strongly suggest that you watch the next video right away, actually, and I'll be putting up the second video right now to complete the introduction of this trig substitution section. Thank you. Goodbye.